todos.
Good morning, everyone.
Dando continuidade aos
Now let's
webinários,
continue with our World Skills Americas webinar, which has the aim of sharing experience in professional education worldwide. And today we're bringing another topic
tecnologias,
in
novas
terms of new technologies and new professions. And I'd like to thank you all for being here, and Mara Corporan from Dominican Republic, who are members of the World Skills Americas board. So I'd like to thank you all for the board and the work that has been developed, and all the other members of the board. Now I'd like to have the next slide.
Temos hoje como
Today
tradutores
we have interpreters, translators, uh, Francisco Javier and Rodrigo Amaral, who will be translating from Portuguese to English and also from Portuguese to English.
para que o próxima, por favor. E para o tema de hoje, novas
And for discussing today's topics, new professions, new technologies, focusing on cybersecurity and also artificial intelligence,
nós temos aqui como
we have with us the speaker, who is Professor Mauritius Bonabitacola de Almeida, who is the director of our information technology community, where he develops this type of content. He's a very experienced professional and passionate for professional education, and he will be sharing about a great challenge that where he is bringing a new unit of education with all technologies and using compatible technologies so that these competencies can be developed. So, Mauricio, I'd like to thank you very much for your participation, for your talk, and for your knowledge sharing, because that's the spirit of World Skills America, which to share experiences so that all the youth and adults can take advantage of that.
América possam sim crescer e nós temos na nossa região uma estrutura social e uma condição econômica mais justa. Então, Maurício, obrigado. A palavra é tua. Eu vou pedir desculpas que eu tenho reunião com o nosso presidente, porém o Merino e o Gustavo vão tocar aí o trabalho. Mona, muito obrigado e compartilhar a sua experiência vai ser muito rica para todos nós. A palavra é tua, Maurício. Obrigado.
Obrigado, professor Espada, pela oportunidade, né? E vamos começar, né? Acho que primeiro, bom dia a todos, good morning, buenos dias, né? A ideia é
Good
que a
morning,
gente
everyone. The idea over here is to work in a very
tecnologia, né? E
slight
voltar
fashion. We'll be talking about technology, and we're going to talk about cybersecurity and artificial intelligence, because both things walk hand in hand today. So I believe that we can get started, and you can move on with the next slide. Let's now talk about the scenery. Today, we know that everything is interconnected. The ecosystems are very complex, and these ecosystems are appearing in every business scene. So if we have to go back in time in the 1950s or 60s, let's imagine a car maker. So they wouldn't have to focus on having good professionals so that they can manufacture good automobile. But today things are different. Nowadays, it's not only about having a good automobile, mechanically speaking, and then have the electronics as well, but nowadays this automobile has to be interconnected. So we are talking about many different skills working together, and this ecosystem is very complex because you have to connect this car to the network, to the web, to applications, and this car will have all technology, and it will have to be connected to a network. And today we can say that the ecosystems are very complex. So we have professionals, and we'll have not only one type of professionals within a company, we have many different types of professionals within this company. That's what we call complex ecosystems, because our home, phones, and cars are becoming more and more smarter. And because of that, we embark within a technological ecosystem. I usually say that a technology starts being transparent when you don't realize that you're using that any longer. So let's imagine that we would go back in time in 100 years. Electrical energy, it wasn't transparent because very few people would have access to it. But when energy was constant in the life of people, people wouldn't even realize that they were using electrical energy because we are all the time connected to that. And if you perceive how many times you use electrical energy during the day, I would say that you're crazy because you don't even realize that. So a technology becomes transparent. It's exactly when you don't realize that you're using that anymore. For example, a cell phone, or when you don't realize that you are connected to something, or when you simply get your mobile and through facial recognition, it opens your screen. Then technology is becoming more and more transparent. And when it becomes more transparent is exactly when the complex ecosystems appear to supply the market with that. Over here, I am speaking about basically two axes, which are those that we really work upon in our school, which is the digitalization and the Industry 4.0. I just inserted three items. I know that there is integrated manufacturing, IoT, and other aspects, but I just put these three topics that we're going to discuss today: AI, cybersecurity, and cloud computing. And why did I add cloud computing? Because it's difficult to separate cybersecurity, AI, and cloud computing. So that's why I put these three items over here, because it's part of this repertoire. Because without AI, cybersecurity, and cloud computing, digitalization or Industry 4.0 does not exist. So these are basic elements so that this ecosystem can be operating and can get connected to the whole world. Well, let's now talk in terms of the history. Um, this cloud computing history is important to understand that, and upon these aspects, we can talk about cybersecurity and then AI. I have shared some dates that are more iconic, I would say, in terms of the idea of cloud computing. Like in the 1970s, we would have monolithic, these big size computers. In the 1980s, we have a client service architecture. In 1990s, we have a web-based architecture, which is a www. In the 2000s, we talk about the service-oriented architecture, which is SOA. And this is very similar to software-based strategy software, where a service provider will have lots of consumers that will consume this service, and then can get many different types of service within this architecture, and then the consumers will have access to the system. SOA is the acronym. And nowadays, we start working on services that are cloud-based. And that's the history in a nutshell. Next slide, Gustavo. Still in terms of cloud computing, which is a pillar so that we can talk about other technologies, we can talk about the private cloud. And what is that? It's a cloud where my infrastructure is the one that I assembled within my business. So software, servers, computers, everything was set within my business, and there are specific characteristics for that. The private cloud has the need of a high investment because of hardware, a continued cost of operation because you need people to be operating and making upgrades on this infrastructure in terms of software and also hardware. And it brings additional costs within your facilities. The advantage is security and total control because it's a private cloud and only you use that and only you consume it. So security and control is yours, but the cost is continuous because if you don't have people and employees that will be dedicated to this operation, the security will go down the drain. A public cloud, um, it, it will bring more risk in terms of privacy. However, it has a high performance. It has also a low cost and scalability. And then here we have Amazon, Google, Microsoft, among other providers as well. But this infrastructure is not allocated within your business. It's being used in a public fashion, and others are also using that. I'm just going to reserve a space that I can use these services. And we also have the hybrid fashion, which is the one that we use over here. Part of our training sessions and our services are within a private cloud, and another part is inserted in a public cloud. In terms of strategy and MVP, for example, or prototypes, we keep it in the private cloud. And while we think that it can be more corporate, we work in a public clouding. So that's the model that I have. So I have both a private and public clouding. So we call this structure a hybrid infrastructure. Let's go to the next slide. And here we have different types of services that a cloud can have, which is SaaS, PaaS, and IaaS. So service is SaaS, so the software, which is the service where I have this service. And when do I have that? It's when I have apps, applications that are installed. For example, that I have Office 360, and then I have some services where I'm going to use an app. That's what we call the SaaS. And now we have the PaaS, which is the platform as a service. And the platform as a service are development tools like databases, BI, business analysis, and then we use a platform and software so that it can develop an app or a management. That's what we call PaaS, or platform as a service. And then we also yes, infrastructure as a service, and then I'm talking about service and storage, firewall security, network, and construction, data center, physical plant. So we're talking about the network infrastructure, and I don't need to have it within my business, my company, my facility. So I can have these elements in terms of secure network firewalls out of my facility. It's also capped in the cloud. So we have service, platform, and also infrastructure. There are other terminologies for that, but I don't see any reasons to bring here. But we have CAS and FAS as well. But these terminologies are also inserted within PaaS and IaaS because they were just subdivided. But in general terms, these are the three lines of services that can work within a cloud. Let's now go to the next slide. Now, talking about the clouds, let's now bring the AI concept. That's the history of AI. As you can see, in 1956, the idea of AI, which is not new, let's say that it's been widespread, and it started in 1956. And then in 1966, we had the first chatbot of the world. In 1981, we had one computer controlling other computers. In 1997, we have the Deep Blue by IBM because defeated Gary Kasparov, who was a world chess champion. And then I'm talking about AI here. In 2008, we have Google app with facial recognition and speech recognition. In 2015, we work with facial recognition, detections of human beings, and then we can talk about transparency of AI. It becomes transparent because you don't even realize it exists. For example, when we are talking with a bot on a website, in fact, we are using AI, or when you unlock the screen of our cell phone and we use facial recognition as well. And this transparency kinds of scale up. And why that? Because if we went back in time some decades, and in order to develop algorithms based on AI, we wouldn't have to have um, the knowledge of physicians, mathematicians, but today we really work in a way that we are using algorithms from 2016 and 2017 on. The cloud-based work can be done by using ready-to-use algorithms, Google Clouds, or any other kinds of players. So today I can work with small blocks that are ready to use. I don't need it to be a great mathematician or a great creator of algorithm, because today we can use structures or semi-ready infrastructure, and then we call this codification as low coding. It's the usage of AI. I don't need to have a deep knowledge of on cognitive algorithms, but I can use these algorithms within my apps, my websites, and I can use AI, just bringing the resources that are available in the cloud. And then we name it as low coding. Transparency of technology is not only becoming transparent for users, but it's becoming easier and easier for technicians to work within these new technologies. Of course, there is an infrastructure of engineers that work on AI, but today, a technician to have a simple training, this person can already use algorithms within cognitive service of a cloud.
E aí a gente está falando agora
Over here,
do histórico de
we are
cibersegurança, né?
talking about the history of cybersecurity, because the idea is to have a cloud, computer, cybersecurity, and AI in a single position. And here I bring the history of these three pillars. And in terms of cybersecurity, from 1971 on, and in terms of 1971, it was the idea of creeper and reaper, and which is what these two things that creeper were one of the first virus that were connected to ARPANET in the 1970s, because it was ARPANET, it was not www. And at that time, it was created to infect mainframes, VDPs, KDAX. That was the idea of these virus, Creeper and Reaper, that was attacking ARPANET. At the end of the day, it simply would send messages or saying, I'm Creeper, catch me if you can, things like that. I wasn't even born at that time, but I know about the history. And the idea behind that was having the first virus within ARPANET, and Reaper is an enhanced version of Creeper, which was launched to be copied within ARPANET and removing Creeper. So Reaper was the first antivirus of that age. So the idea in terms of cybersecurity started in 1970s, the early 1970s. In 1988, we talk about the first network freeze, and here I'm talking about the DOS cyber attack. And the first DOS cyber attack happened in such a way that it was an accident very close to the creation of the microwave appliance. The first DOS cyber attack was accidental. The idea was to launch warn code to measure the size of ARPANET, which was the internet of that time. But unfortunately, it was replicated and it created some huge traffic within the network. And because of that, there was a network freeze, which was a 10% distributed in terms of service denial, which was a DDoS cyber attack. So that's the one that happened in 1981, that happened in 1988, accidentally. In 2002, there was the creation of the Department of Internal Security in the United States that was created by George W. Bush with the aim of providing protection of critical infrastructure of the United States. In 2003, we had the birth of Anonymous. It was a group, the first group that we know about in terms of activist hackers. And they invade the machines, they are international, so it is an activism-based hacking group. And they attack some businesses that operate under concepts that they don't agree with. In 2009, we have Aurora operation with a series of cyber attacks, and they were aiming big tech intellectual property assets like Google, Adobe, Yahoo, Microsoft. And because they wanted to collect information in terms of intellectual property. So our operation was widespread in 2009, 2010. Here we have Stuxnet. Stuxnet was a warning for attacking an operational system that would have the function of messing up the SCADA operational system. It was a system for critical infrastructure control, and it was one of the first viruses that would have the attack against military protection, and it's one of the attacks by Stux happened within Iranian whirlpools, and this virus in such a way happened not through the internet, but it happened through a flash drive in a whirlpool of iron, and there was an alteration of RPMs in the whirlpool that was very subtle within the Iranian whirlpool, and at that time it damaged this Iranian whirlpool. So that was the first attack in terms of the military facilities for critical infrastructures. And in 2017, we have Eternal Blue, which is an exploit that attacks protocols of Windows SMB, and through vulnerability of non-updating of some patches, it identifies where the systems become more vulnerable, whether within these failures they attack. In 2018, we have the idea of a cloud computing and IT as a driver for all types of devices and connections with IoT and hardware. Then we have the need of have a general data protection regulation by European Union, which is GDPR, which is the general regulation for data protection created by European Union. Here in Brazil, we have a similar law, which is the Brazilian GDPR that was started in 2018 as well, but was put into action here in Brazil in 2020. In 2020, we talk about the Twitter hack, which is the Twitter account hacking. And it's interesting because it stole Elon Musk, Bill Gates, and Barack Obama Twitter accounts, and they would request a big amount of money so that they could recover these accounts. And then we in 2022 have a high increase of home officing, and with this booming, it happens in 2020. And we have a big connection of everything. And then today we have cybersecurity enabled by artificial intelligence. And here I need to have a big security. So cybersecurity with AI is has a very big connection because cybersecurity is only enabled if we have AI. And then we can provide a response in a proper fashion. So AI is the driver that will provide a better means for cybersecurity. And then we think about chatbots, facial recognition, but AI is present in a transverse fashion and present in every different technology that we have got in IT. So today, if we have got a connected world where I have applications that are run worldwide and assets, devices that were not connected in the past, but now they are connected to the network. So today, I need to have the cybersecurity at the same level. And for search, AI is going to be an enabler for some operations and having a faster response and even have predictability in terms of incidents that might happen. And today we cannot detach the clouds from cybersecurity and AI. And let's now go to the next slide. And here I have got some expectations for 2025. And that's a prediction of expectations in terms of values for AI development and also cybercrime and the intersection of these two things, because I want to bring the intersections of cloud computer, AI, and also cybersecurity. The forecast of the global markets in terms of AI might reach something around 190 billion in 2025. Cybercrime until 2025 in terms of frauds or data theft and among other things, which is cybercrime, it must cost around $6 trillion by 2025. If we could measure that by country, it would be the third economy of the world. It would be just behind China and the United States. And if I have the intersection of cybersecurity and AI and the usage of AI within cybersecurity, so this technology must move around over $30 million until 2025. So that's a intersection of AI and cybersecurity, so that you can have scalability. And let's say that we would have an idea of response to incidents in a more precise fashion and quicker in this interconnected world. If I have to compare, and a basic comparison of all these aspects, I can say that the websites and apps and all the softwares that are run today, they would be the means of transportations. They would be like buses, cars, motorcycles. And I would say that the streets and the roads would be my network infrastructure. And the signs, the traffic lights, and the laws, they would be cybersecurity. So let's imagine that we have the road system and not having all these things developed, well developed, it would be total chaos. So one thing really depends on the other, and one thing is interconnected to the other. So if I have great applications based on AI or on websites, but if I don't have a proper distribution for all these things in a consistent fashion within networks, it won't work. And I also have to have cybersecurity so that I can have everything up and running. Everything has to be interconnected. Let's go to the next slide. Over here, we have some professions, the main one, not all of them, and the ones that are really valued over here in Brazil. And you can realize that these professions, they have something common. They have a very specific degree of technology. I'm talking about cloud analyst in terms of cloud, infrastructure analyst, cloud architect, edge computing analyst. These are professionals that they work directly with cloud infrastructure. And then we talk about cybersecurity, and I'm talking about DPO, information security analyst, security hacker, virtual forensic expert, cybersecurity analyst. These are professions that are already here. They're not about the future, but they are going to be developed upon these environments. And in terms of AI, we have machine learning analysts, app developer, and the app developers are very important because I need to have them so that I can have a chat box and also facial recognition, and then I have low coding over there. And they need to have data scientists, big data analysts, marketing automation programmer, machine learning programmer, and all of them are directly or indirectly connected to AI. And talking about world skills, we have some modalities that are interconnected to these professions. In world skills, we have directly connected to 53, which is the skill addressed to the cloud, and 54 that is addressed to cybersecurity. And probably we'll have studies for future skills that would be AI. The name would be machine learning and big data. So that's a study that we had some competitions at with BRICS that was addressing machine learning and big data as well. But I think that in general terms, it's transverse to all the others. But these professions will be really booming, and I would say that they're already booming. I would be redundant if I say that they are coming with strength in the future. And road skills are already signaling that, and it has these modalities that are addressed in its competition. And now let's go to the next slide. Over here, I have our unit. It's a school, an IT school by Senai, which is located in the big center of São Paulo. And today, I will be talking about what we have within this unit and how this move into another unit is going to be that will really increase this new ecosystem in terms of the industry and technology. And today, our Senai IT school is located in the city center of São Paulo, where the facility has 4,500 square meters and 3 systems developments, 4 laboratories and 3 labs for computer networks and 7 IT labs that these are generalized labs. We also have a cybersecurity lab and a multi-purpose environment on top of an auditorium for 100 seats. And today we have 975 students per day in the technical fields, free courses, and also training courses for MBAs and higher education. So we have a total of 975 students per day being served in our facility. Well, with regards to our labs, we have to think about what we mentioned in terms of clouds. We have a hybrid infrastructure where a part of what we do is within our servers, within our private unit, and some other things are in the public cloud. And here I talk about AWS as a partners. We work with many different types of partners, but AWS, Google, and Microsoft, and Oracle and Cisco are the partners that we have got because we work with public clouds within these players, which are our partners within our facility. These labs are the ones that we develop the following things. We work with GDP, the Brazilian law of GDP, and also with ISO international certification. We have 27001 and 27701. And we also work with Pentas and also with social engineering, because we have to bring social engineering, because if I'm only focusing on technical issues, I will have sophisticated devices, sophisticated software, but if people are not good, we are going to bring problems for users, and the engineers will have problems. So social engineering is still one of the aspects that we really work on in order to avoid invasions in terms of cybersecurity. We also work on the review of information security policies, and these security policies are revised by our lab. I mean, when a company wants to develop a security policy, they are revised by us and develop these information security policies developed with our students in partnership with other companies that can use them within their institution. Now let's go to the next slide. Over here you have the main partners we have got, with whom we work in our facility. And these are the main ones that we have got and can realize that they are interconnected with the cloud. That's why the cloud is so important. And we work with Microsoft from AZ900, Line, AI 900, DB 900, that is for AI and cloud computers infrastructure, and data science as well. These are the critical ones. But even within the expert and specialty, we have the Microsoft as a partner. We have AWS with cloud practitioner, and we also have the architects and DevOps and other certifications are worked within our classes and our courses and trainings. And we also have Google Clouds. We have Google Clouds, and we also have machine learning and AI by Google. And we also work with Cisco because these are standardized international certificates. And we are also working with Cisco within cybersecurity, and we're going to have a new certificates in terms of cybersecurity, and I'm working with Cisco. And we also work with Oracle. These are the main partners in terms of certificates that we have got within our course and training sessions that we have to work with our employees and our students, because we train both the trainees and also the students and also the employees. And we work on our practices with our employees. And when our employees become specialists, they teach to our students in the classrooms. Let's now go to the next slide. Here we have some training courses we have got within our facilities, and have the images of some of our labs, and we carry out these trainings. And here we are talking about hardening, penetration tests, pen tests, forensic analysis, monitoring, many security tools, game hacker, and also hyper-realistic cyber attack and defense simulation. And I'll be covering these these courses. And AI is also included within these trainings, so you understand better why I'm saying that. Now let's go to the next slide. One of the tools that we have got within these trainings is the hyper-realistic cyber attack and defense simulator, which is a partner that is CMORC by Hostcom. It's the same simulator that the Brazilian Army uses. So through hypothetical sceneries, we create hyper-realistic attacks, which is an emulator. It's not a simulator. So the emulator is really happening. So we just copy some infrastructures by some companies and we apply that to our students. Then we work in a really realistic fashion with the company and the Brazilian industry. So when an industry wants to test a scenery, copy this infrastructure of this company with this simulator, and upon that, our students will execute the cyber attack and cyber defense, which is the blue team and the red team. Um, so companies work on that when they want to build a new infrastructure within their technological park, and they bring this technology, and we don't want to stress their real structure. So we bring that to our simulator, and upon that, we run all these cyber attack and defense tests with training for our students. This is one of the tools that we have got within our lab. Let's go to the next slide. Cyber war is a game that was developed directly by our employees. The other one is a scenery simulator, but this is a cyber attack and cyber defense with commands of blue team and red team, but there is no scenery. So this software is programmed by AI, so it tries to memorize and it learns the way that blue team defends and how the red team defends, and it creates automated commands and sceneries when there is a dispute between the blue team and red team. So the difference between the CMOC and Game Hacker is that the other ones was with real infrastructures of companies, and this one it only uses hypothetical sceneries, and through AI, it can understand the way the blue team or the red team operate, and it creates situations where they are not prepared. And here we can train our own employees upon this tool because they have timing and it's like a competition so that they can be fast to attack and even faster in a defense. So that's the idea behind Game Hacker. This software and this player over here is developed within our context here in Senai, São Paulo, that was developed for training our employees. And we work on our infrastructure, and everything that I'm showing you here is within the trainings that we use in our facility. So we have a honeypot. The honeypot is exactly the following. When you create something in our physical infrastructure, in this case, you created a physical infrastructure, and on purpose, we created openings so that there could be a cyber attack. And that's why it's a honeypot. It's a trap where we attract people as hackers so that we can understand it and just know where it comes from and what is the standard of attacks that are happening. And then we open this honeypot within our infrastructure, and in the last scanning that we did, we could see the main passwords that were used, the main ports that were used, the main users as well that were being attacked, and what are the main countries where these attacks come from. And we know that it can be done in a deviated fashion, but we understand the pattern of these cyber attacks. And with the protection of the ports and the passwords that can be performed, we can have an idea on where the biggest numbers are. For example, the ports that were attacked, the password that were used, administrators that were used, and where you have the colored mapping, it will have this real-time mapping, and then we can see how these cyber attacks are done, and you understand this standard, this pattern, and then we apply this tool with our students for networks and cybersecurity. Now let's go to the next one. We also have a SWAR platform, which is a vulnerability mapping tool, and SWAR, which is security orchestration, automation, and response. And through the registration of networks and assets, I can have even an URL, a website that we can register this infrastructure, and through automation, and again, using AI, we can show what is happening in a very objective fashion using the open source. And it's bad when you use that separately because you have to provide separate reports, but we create a platform that upon ISO 27000, we can standardize the responsibility and the degree of importance of that specific attack. If that cyber attack, for example, is critical for the business or not, and through a registration on this platform of assets, we can do it. And this platform is the SOAR. And for those that come from this student know what it is. This is a orchestration platform where we can have an idea of response automations on events that are taking place within a network. And how do you use that? We use that with the students registering and inserting some infrastructures over here that we created in our school, but they are segregated in our current network. And then we can work with the students in an objective fashion. And how do we work over here? We identify the asset registration, what is going to be registered. And when I talk about asset registration, I'm talking about not only about physical device, but URLs, websites, and everything that is within my network and that has an IP. We scan everything before we did that manually, but now we do that automatically. And there is AI here and it scans everything, validates the results, and it to give you the extraction of results and everything that the students have to correct. These are the 4 steps we have in the SOR platform. I numbered everything here in terms of registrations that we have got for the first assets. What can I register? IP, the IP range, the URL, the domain, FQDN, and there are many other things that you can register within a network. So over here we have some educational networks that are proprietary and internal for Sinai, where we can make the platform registration so that we can test it, and the MVP test for our students. So we register all these assets, these goods, and after doing that, we scan these assets through CVS and CVSS as well. We have a ranking over here, and we work with certificates of IP, FDN, domain URL. So these are the names of the open source certificates that we scan, and we check what's happening within the network. Over here, we have an example where we scanned 11 assets, 109 events, and the total number of sensors that were active, which are the ones that are certified and used. And it's going to bring you an answer. And upon this scanning, it's going to give you results. It's worth mentioning that behind that there is AI in order to validate these results. So right after scanning and having everything with parameters, we can validate and understand what's happened because it can promote training and consulting. So the students through the reports can work on cybersecurity within that network environment. And upon that, we can have AI and we can conclude the procedures, for example, for that blue team that will have to work on that in order to validate those results that were scanned within a network. And now the reports are diverse. We have many different types of reports, and these reports, in fact, they are automated by our software. It recognizes the number of assets, and it summarizes everything. And we also have the JSON results. So it extracts all the results, and then we have the conjunction of things here. Because if you do that manually, I mean, for example, one report after another, and then I would have to have a technician to do that. The response to an incident would delay too much. But when I have AI that understands the result and proposes reports, I have a student to work on that. And these result extractions work in this way. Over here, we have the summary of assets and what happened to each asset, and it's in Portuguese. We translate that to Portuguese so that our students can work here, but it can be done in any language. It shows what you have scanned, what group was used, the rate in terms of security that is based upon ISO 20 to 27001, and it provides you the kinds of corrections that must be performed. And this is the report of that specific asset. In this asset, we have a risk-based matrix that is also ranked using ISO 27001, and here it's the asset. The previous one was for the group, and this is specific for an asset. And it can have patch updates and other things that are detected, and even the asset report through AI can assemble everything to you and understands what are the situations that are taking place at that moment in the market. Next one, we have the detailed report for that specific asset. It's done in tables, and it shows what has to be done and what were the mistakes that were found in these assets and what kinds of scans that were performed. And with this, we have a detailed report. And with this, the students understand how it works and it goes to the field so that we can work upon that and correct these vulnerabilities that are detected. And it's done in a more effective fashion and also quicker. These are the results in JSON for the process automation. And here we have a lot of AI together. And here I can understand and show my student by using AI, machine learning, and then can understand patterns. And with this, the response to the event is way faster. And here is the report and how the companies work on that. So this is an acceptance letter, and then they put everything in a specific fashion so that they are responsible for the detailing and the work that is going to be done within a network for working on the vulnerabilities. And the software that we use for parameters, we use the GDPR in Brazil so that our students can understand what law is really covering the critical network regimen. The law that we use over here in Brazil is from the 45 to 55 provisions of the Brazilian GDPR, because it talks about the cyber attack on infrastructures and data protections of customers. So we have to work with the students providing this information related to the Brazilian law. Basically, all our courses, they permeate all the legal and technical aspects as well, so that we can cover the Brazilian laws as well. Well, we developed this know-how within our school, especially here in the state of São Paulo. And the school where we are today is small, and now we are moving to another unit. And its new school will be inaugurated in 2023. Next year, it will be bigger, and it will have a higher education course, technology, training course, certifications as well. And then you will see that the number of labs really increases. So 3 for system development, 3 for network, 3 for gaming. So we're going to work strongly in this unit, and that's why I say that AI will be transverse to everything. So this lab for games, we will work with metaverse and simulation and 23 IT labs. And one auditorium, one multi-purpose environment, one cyber arena, and also a library. So this school is designed to serve over 1,500 students that will be trained in cybersecurity and AI and cloud computing every single day. So over here, we have some images of this school that is already built. We are now just concluding the works, and the inauguration will probably take place at the beginning of 2023. These are some images. This is the arena that that's already assembled, but it's a cyber arena that has got 363 square meter for red teams and blue teams, and all those softwares and these parameterizations that will occur within the space is segregated network. It's not a corporate network. The network will be only for it, and there is a redundancy as well. I also recommend this, although it's in Portuguese, when we talk about social engineering, which is one of the most one of the biggest vulnerabilities in terms of cybersecurity. And as I said before, it's worthless if you have a team of professionals that are well trained and top-notch software and equipment, but if you don't have an attentive user that is really ready to respond to cyber attacks. And then we have this YouTube channel when we have a series that we record with our specialists within our labs over here in Sinai. And they were talking about social engineering and cybersecurity. So these are 16 videos that are very short. It's 1.5 minutes or 2 minutes that talking about social engineering and the types of attacks that can take place within this model. For those that understand Portuguese, I believe it's worth watching it, or you can even use subtitles, because the terminology is internationalized. I believe it's really good to watch that. And we have already launched the other materials, but that was the first one that we did with cybersecurity. And that's my presentation. I'd like to thank you very much for your attention, for your time. And I really hope that I was objective. I had a short period of time to talk about so many things, but I wanted to finish within the time that we could conclude that within 1 hour, because I don't want it to be a problem for your schedule. So thank you so much for your attention and opportunity as well. Dear Professor Mauricio, thank you so much for sharing your knowledge and your experience, and to WorldSkill Americas. So now we're gonna have a Q&A session. So when you have a Q&A, when you have a question, please say your name, the country where you come from, and Gustavo will bring the questions to Professor Mauricio. Hello, Professor. We have three questions from Guatemala, Ivan Galindo. How the organizational structures should happen for departments and IT departments to deal with cybersecurity technology in terms of size, proportion, and he even gave an example for this. The number of technicians and for the amount of IT labs, the number of engineers and servers, the idea of dimensions. Hello, Ivan. The dimension really depends on what you want to attack. It's difficult to talk about numbers over here because it depends on your infrastructure. Remember that at the beginning we talked about an infrastructure that was private, a private cloud, or a public cloud. And when we talk about a private one, probably your employees will be the specialists and need to have engineers, and it really depends on how much you want to propagate in this private clouds, and the infrastructure belongs to your company. So you need to have a 24/7 security analyst working. So it's really expensive. And you need to have SOC monitoring. I would say to you that for a medium-sized server monitoring, you would need at least 6 employees, the security analyst, and then you have different three levels of analysts, 1, 2, and 3. In our unit here, because of our characteristics, we have 6 employees that take care of infrastructure, physical infrastructure, and also cybersecurity in our unit. Just for to have an idea, we have 12 labs. When you have a public infrastructure and when you are working with the cloud, probably it's going to be reduced because you don't have the hardware team to take care of that because you're using all the services in the cloud. And usually this number of employees is reduced. In our unit, we have the hybrid way. We have a private, the public, and hybrid. So we have specialists that only work with the cloud, with the cloud security, and we also have people that work with physical part, the infrastructure, which is smaller. So today in our unit, we have six employees for 12 labs. In the other unit, we're going to have 33 labs. So we are thinking about another number of employees, and we work with the hybrid system, and we have private and public clouds. So probably you're going to have around 10 to 12 employees in terms of cybersecurity analysts and engineers. Yes, I believe you have answered that. He also had another question in terms of budgeting, and in terms of maintenance, investments for the labs that you showed in the presentation. The investment, just for us to have an idea, it's this lab has the software which is more expensive than the hardware. In terms of infrastructure, I would say that it's a lab that trains around 20 people at a time. That's a recommendation. So 20 students simultaneously studying in a lab. So in terms of the amount in dollars, for us, the infrastructure, I mean, servers. And remember that some are in the cloud and some others are software that we developed in-house and some software developed in partnership with other companies. We spent around $100,000, $100,000 for a lab to serve 20 students at a time. And the next one that we are building in São Caetano City, the new school, it is more specific and will serve the double, 40 students at a time. It will be around, it only for cybersecurity lab, it will be $300,000 investment. Thank you, Professor. We have another question in terms of the courses. What is the level of education that the students need to have? A bachelor, engineer, a technical graduation? It depends on the type of the course that the student desires to study. If I have a cybersecurity in the first and second level, which is the most basic ones, which is basic, but not that basic, because these students must come with a technical specialty in computer networks already. So I'm not talking about the level of education, but the knowledge per se. So they need to have the TCP/IP layer, what is a service, they need to know what is virtualization, virtual machines. So if the students come with this knowledge, the level of education doesn't matter. But here we have younger people, and they are around 17, 16 years of age, and they are close to joining university. That's the university, that's the students profile that we have got here. Thank you. We have further questions here by Luis Felipe from Chile. It says, for example, how can Chilean students can have cloud computing certification with Amazon, for example? Hello, Luis. For example, Google or Amazon, they are global companies, and then in fact you have to join their platforms and register your institution over there. Here in Brazil, for example, through Senai São Paulo, we established a partnership with Microsoft, and from this partnership, our professors, teachers, they were certified, they were trained, and they have credits so that these students can work in the cloud. So Amazon, for example, has a specific model, Microsoft has another model, but the first initial idea is that the person who is responsible for institution have to get in touch with these the representatives in your countries for these providers, and then you have to establish an educational partnership, make this registration, you have to have this training with your employees. At least that's what we did here in Brazil. And from that moment on, the certification will be provided in the institution, and the students will use these credits throughout the course. We have another question over here that comes from Alicia Williams that asks, is there a way of for us to provide support for some other countries that have a few specialists in AI and cybersecurity? Yeah. In fact, we are now developing know-how so that we can do that remotely. Today, we don't have this consulting, this training overseas. Why? Because we have some restrictions in terms of laws, and we have to understand and how it works. For example, here in Brazil, we have the Brazilian GDPR, but you need to develop, we're developing a long distance education that will be made available in our platform, and this long distance learning will be provided to any country so that these countries can develop their know-how as well. But in terms of more technical consultancy, it will depend on having these specialists that will understand the law of the specific country and what that country will need. But we can do that remotely and can monitor the assets, for example. For example, the SOAR platform, and through VPN, we can connect to your infrastructure and I can monitor everything and I can check all the vulnerability of your system. We can do that remotely. Perfect, Professor. I have one more question. It's by Dave Moore from Jamaica. He is thanking you very much for a presentation. He really liked that. And he wanted to know if we train SCADA specialists that is using their industry. Yes, we train. And when we talk about SCADA networks, that is for critical infrastructure, we have a unit over here to train these specialists. And then we use the Siemens SCADA. We use the Siemens one, and we have the training on SCADA networks for cybersecurity in critical infrastructure. And we do that because when we talk about Senai, this facility is for cybersecurity and networks and IP, and not so much in terms of infrastructure and also AI. I don't know if you attended part of one talk from the other units. It also works in terms of training for SCADA. And we have a partnership here with the Brazilian Army for training using SCADA. Great, fantastic, Professor. Let's now have the last question by Rafael from the Dominican Republic. When we have knowledge on cybersecurity, can we determine who attacked us or where this country came from? Where this attack come from in terms of the country? Well, it depends on the attack, if it is sophisticated or not. If this attack is not so sophisticated, you can track that very quickly and easily. We have tools for such, and our honeypot software can make this tracking. And we developed that to do so. But when the cyber attack is so sophisticated, it uses IP masking tools. So sometimes a person, for example, is in Peru, but this person is using an IP from Sweden that will hit Ireland, and then it's more difficult to find where these attacks comes from because they're using different types of countries. So you can reach Peru, for example, but you cannot get into more details, other levels without getting in touch with these countries. So it depends on the sophistication of the attack. But if they are more direct and simpler attacks, you can detect and track that very easily. But if it's a more robust attack, you have to get in touch and you have to track the knots, but you have to really get in touch with other countries so that you can get their help so that you can reach the origin of the attack. The more knots you have got, the more difficult it is to track this cyber attack. And there are some countries that are not so prepared to provide this tracking. Thank you, Professor. Thank you for your answer and for your knowledge. And now I'll give the floor to Marino, who will provide our final consideration. So I would like to thank everyone who participated in this webinar. It's one more World Skills Americas webinar with Professor Mauricio Bonham, who shared his knowledge, his experience with us, and the future that is not the future anymore because it's already among us. And now I'd like to invite all of you to our next webinar on the 30th of the next month, on June 30th. We're going to send you the invitation and we really hope to be together with you. Thank you so much. And thank you, thank the interpreters, Professor Bono and everyone who participated, and Gustavo. Thank you all. Bye-bye. Bye-bye. Thank you.